Happy Saturday. This is Brent with Lykins Motorsports. On this episode, we're going to be file fitting and going over some basic piston ring installation. This is our 397 tunnel port block, and we got the pistons ordered from Racetech, and had these rings on order for a little bit from Male, and they are finally here. So we're going to get started on some piston ring stuff. Still waiting on some parts to come in and some machine work, so it's pretty common for everything post-COVID. Things are just a little bit slow, and I just kind of bounce around and do what I can to stay busy in between all the phone calls and emails and orders that I get for parts. But today, yesterday I took a little bit of a break and did some shooting, and today we're gonna work on our side oiler block and get our piston rings filed. All right, so let's take a minute and discuss what's necessary to choose piston rings. Obviously, the first thing that comes to mind is your bore size. Rings and pistons both have to fit your bore size. Rings are available in drop-in and file fit. Generally, if you see a plus 5,000s at the end, it's a file fit ring. And it says file fit. But if it doesn't say file fit, that they're allowing for extra material to dial it in. Drop-in rings are, I guess, for the guys who, they don't want to put the effort into it, or they're not familiar enough with engines to be comfortable with filing rings. The issue with drop-in rings is that the gaps could be anywhere. They are allowing for enough end gap to make sure that the ends don't butt under heat, and that's not always a perfect scenario. The piston ring manufacturers specify a specific ring end gap, and they will even go as far as to talk about forced induction applications, higher horsepower applications, that sort of thing, and you have to adjust the end gap for the particular engine that you're working on. Okay, the next thing you need to look at is the ring thickness. This particular ring pack, the pistons, I ordered them custom. They are 1 millimeter, 1 millimeter, 2 millimeter. So your first and second rings are 1 millimeter. Your oil rail and your oil pack assembly is 2 millimeters. So your expander and your two oil rails are 2 millimeters thick. Technology is bringing us to thinner and thinner rings, and they are more efficient, less drag, but they still maintain a good bite on the cylinder wall. So, older FE pistons, you would see a 5/64, possibly a 3/16 ring pack thickness. Those are incredibly thick. And when you put engines together and you get a short block together, you can put a torque wrench on it that shows, breakaway and continuous rotating torque. And these smaller, thinner rings are completely different in comparison to the older 5/64 rings, and even the 16th inch rings that, were popular 10, 15 years ago. In addition, I use a tapered ring compressor, and the amount of force that I need to use with my thumbs to push the piston down with the rings on it, completely different between even the 16th inch rings and these 1 millimeter or 1.5 millimeter ring packs. Your pistons will dictate which rings you use, and your pistons will dictate even the ring manufacturer sometimes. So if you buy an off-the-shelf piston, the ring grooves will be made for probably a specific piston ring, and we'll talk about that in a minute. If you custom order your pistons, then you generally give them either a part number for the rings that you're going to use, or you'll give them ring grooves and land dimensions. You will see horsepower increases as you get from the thicker rings to the smaller metric ring packs. Generally, like the difference between a 16th inch and something like a 1.53 millimeter ring pack, if you have both standard tension rings, 10 or 15 horsepower. After that, you have essentially diminishing returns as you get thinner and thinner. Now, I could have went, there's all kinds of thinner rings than this. I think 0.7, 0.8 millimeter. They can be incredibly expensive. So you have to weigh your cost versus benefit. In something like a NHRA Superstock build or something like that, where they're, jonesing for every single horsepower, then they would pay for those more expensive ring sets. For this application, this is a good cost versus benefit for this application, for this tunnel port engine. I think these rings were somewhere around $250, which is kind of not cheap and not too expensive either. So this is a 1 millimeter. This is your top ring. These are very thin and completely different from even the 1/16 rings. The reason that I mentioned a minute ago that if you're buying shelf pistons, then you need to buy rings that fit. If you buy custom pistons, then you need to either specify the ring pack or the dimensions. It's because not all rings are made the same. This dimension here is called your radial thickness, and this dimension is your axial thickness. So your radial thickness will vary depending on piston to piston, and sometimes piston manufacturers will change how much room there is behind the ring groove, or how close it is, how much clearance you have between the groove and the ring. There is power to be made in that area, so it's good to do your homework in those ways. So what I'm going to do now, we'll go through and I'll show you the process that I use to check out the current end gaps, what they want to calculate, what they need to be, and then we'll show you how to gap the rings and to dress them and clean them up. Most of your piston ring manufacturers will give you a general rule of thumb as to where to set the end gaps, and they'll give you these formulas on your oil rails, which are these little dudes here. There's a minimum that you need to check for, and you put those in the bores and use a feeler gauge and see where you are. On your first and second rings, there's also guidelines. These are just general guidelines. So sometimes depending on the horsepower that I'm going to make or the application that I'm going to make, I will give the piston ring manufacturers a call just to bounce some things off of them, and so there's no surprises. I did that with our 496 forced induction build. It's a rather large bore size, potential to make a lot of horsepower, a lot of boost that we're going to be putting through it. So I rang up my contact at Total Seal and bounced some things off of him to get his recommendation. I never run below this 4.5 thousandths per inch of bore number. So even on a very mild street engine, I will run 4.5 thousandths on the top ring per inch of bore, 5 thousandths per inch of bore on the second ring. And the higher the horsepower, the more heat that's going to be in the top of the cylinder, in the cylinder head. More heat shrinks that end gap up. So when you have higher horsepower, you need to allow for more end gap. This circle track and drag racing doesn't always, necessarily apply. This 5,000ths rule could be for a very high horsepower, naturally aspirated street engine, and you just need to do your homework on where to set the gaps up. For our tunnel port engine, this is where I'm going to be. So 5,000ths on the top ring, 6,000ths clearance on our end gaps on the second ring, because I have a good feeling I know what the horsepower is probably going to be, and it is naturally aspirated, and even though it may be used on the street, we don't want those end gaps to come together. So for our 4 1/4 inch bore, our top ring is going to be set at, I think my calculator is getting ready to die, 21 thousandths. I'm going to check that with my phone here in a second. I don't really trust this calculator. And then 4,250 times 6. So that's showing 25.5. I'm going to go to 26. That those two numbers don't jive, so or they don't jive in my head anyway. So I'm going to hop off here and use my phone and double check the numbers. So I've got our side oiler block unbagged, and I'm just going to sit and look at it for a minute. You don't, when I was a lot younger and started messing with FEs and everything, you always held the 427 side oiler in such a high regard. And at the prices that, they fetch sometimes, you just sit there and think, oh, I'd like to have one, but I'll never be able to afford one. I've been able to own 2 in my lifetime, and I don't know. Every time I pull the bag off or look at it, I don't know. It's just like looking at something you've never seen before, I guess. I don't know how else to explain it, but you just kind of look at it and wonder what kind of history it had. This is a service replacement block, so it wasn't present in any factory production vehicle, but obviously it's been ran. It wasn't new in the crate or anything, so you just wonder, what car has it been in, who owned it, what kind of application it's been used in, that sort of thing. It's got a history. I'm sure it could tell some stories, but it's just a nice looking block. All right, enough of that. So got our rings laid out. My calculator was correct, and it just didn't look right to me for some reason, so I double checked. But what I usually do is just lay out. I'll do one cylinder at a time, and I'll lay out my oil rails and my expander, and then top ring and second ring. This is what's called a Napier second ring. I don't know. Let me see if I can get my phone to focus. Let me get a flashlight so you can see. So they got this little lip on the outside edge. I don't know if you can see it, but you can feel it. It's not very, very big, especially with a 1mm ring. But these rings tend to be a little bit lower tension, so they put that little little lip there to help pull the oil, the excess oil, off the cylinder walls. So that's called a Napier ring. Those are usually on your second rings. But I lay all these out, and you just go through and I have to use a ring tool that will push the rings down the same depth all the way around the bore. I've had that. Summit actually makes a really nice ring setting tool, but normally I kind of stay away from kind of no-name brands like that, but this has served me very well. And you never understand how hard it is to do something until you try to do it with one hand. But essentially, you set that so that it's a fairly loose fit. It'll spin in the bore. And then when you set your ring in there, you can use it to square it up and check your end gap. I'm going to do that now because I've only got one hand. This is our first oil rail I'm checking, and after you do this for a while, you kind of get a trained eye, but piston ring manufacturers will generally say your minimum is 12 or 15 thousandths, and this is more than 15 thousandths. So it's not too uncommon to have to grind these, and when you grind them, it's kind of an ordeal because you have to hold one end with your hand while you grind. Otherwise, they're just so flimsy that they want to drop down and get in the way of your grinding wheel. But I want to go through and check the other oil rail, and what I do, even if I don't have to grind it, I'll dress it on my dressing wheel and make sure there are no burrs. If you do a lot of engine builds, this type of ring grinder is worth its weight in gold. If you are having to rely on an old hand crank type, you'll spend a good amount of time doing it. This, if I go through and determine that all my top rings need 15 thousandths taken off, then I can set my ring to 0, and when I put it down against the wheel, I can just feed to the thousandth. And on some of the AP steel rings that I use, it takes a little bit of grinding because they're harder, but a good molly face ductile iron ring, you can cut 15 thousandths off of them pretty quickly. Plus they have this nice dressing wheel on the side, so when you grind, you can just step over here and touch it and smooth it up. These are about, well, I can't remember what I paid for it. I'm thinking $500 or $600, but this one's made and sold through Total Seal, but they're nice pieces. So when you dress the ends, you don't want to lay into them. You're just taking the sharp edges off, and you're not trying to take away material or cut them way back or anything like that. So it doesn't take much to dress them. You can see that just a bit of a shiny end. So I've done both of them like that. I just run them over my hand and step them over there and dress them. All right, so this is my top ring on the #1 cylinder. And by the way, you need to go through and do each cylinder separately and keep those marked and separated from the other cylinders. But I just put this ring in right out of the package, and I've got just a very slight, maybe a 1/1000 gap or so. So I want to take our top ring gap, we calculate it to be 21. I'm going to cut 20 thousandths off of this and see where it puts us. So when I file rings, I'll generally set my 3 blades. The oil rails were just a little bit getting close on the visual side, so I went ahead and peeled a 15 out just to check. But I've got a 21 and a 26, and feeler gauges are just by feel, obviously, but you want just a little bit of drag. And I'm going to keep on going at this, well, I'll just go ahead and check. The others should follow suit, maybe within a thou or so. But the way that the block sits, when there's no load on the top of it, plays a little bit of a role into it. Our second ring, Napier ring, same deal. It required 24 thousandths of material to pull off, and I cut it and dressed the ends, and we're in good shape. So that is 1 cylinder's worth. I'll get some, since I don't have the pistons or pretty much anything else at this point, I'll wrap it and mark it, which cylinder it goes to, and then go on to the next one. The rest of it's just tedious, repetitive work. I don't need to show you. You probably don't want to watch anyway, but that's the nuts and bolts of it. Thank you guys for watching and hanging out with me. And I haven't given this dyno mule a name yet, but maybe we'll have to come up with one, and we'll give him a name. But thanks for hanging out with us. If you haven't subscribed yet, make sure you do that so that you don't miss out on any cool stuff. And should have parts starting to trickle in a few weeks for this old girl. Pistons will be coming. My tunnel port heads, if you remember, we needed to put one seat in it. The seats finally showed up. Those were back ordered. I'm not sure why, but we'll get those heads assembled here shortly. And our flat plane crank from Windberg will be showing up in weeks. I don't know how many, but weeks. And we'll get it together at some point. But thank you guys for watching, and hope you're having a good weekend, and I'll see you soon.